plot a root locus for a transfer function which is having both the poles and zeros. Let us consider an example in which the transfer function is given like this. G of s, h of s is equal to k into s plus 4 divided by s into s square plus 2s plus 2. This is the transfer function which we are considering. Here we can see that there is one 0 present in the transfer function and 3 poles are present in the transfer function. So we have z is equal to 1, that is the number of zeros, and number of poles is equal to 3, and the values are zeros we have s is equal to minus 4. Okay, and for poles we have the values s is equal to 0, then minus 1 plus j, and minus 1 minus j. Okay, so we have identified the poles and zeros for the transfer function. Now what is the next step? Next step is to we have to draw the real axis locus. Okay, so what we can do is we'll just, this is a rough sketch, so I'm just marking it 0 here, then minus 1 here. Okay, we have minus 4 rows, so minus 2, then minus 3, then we have minus 4 here. Okay, so these are the then here I have j1, here I have minus j1. Okay, this is sigma and this is j omega. So now the first step is to plot poles and zeros on the real axis. So we will be poles first we'll plot. It is, there is a pole present at 0, then there is one at minus 1, so minus 1 j1 and minus 1 j2 we will be plotting like this. Okay, so we can do like this. So we have already plotted all three poles. Now there is a 0 present, 0 is present at minus 4. Now real axis loci is the first one step we have to find. So this is, we can see that we consider a section on real axis on this between 0 and minus 4 and check whether the number of poles and zeros added up to the right hand side of that point is odd number. If it is odd, then we can say there is a locus existing in this region. Now you just see any, take any point here, and if you can see that only one uh, pole present on the right hand side. That means there is an odd number, so that means it is a, there exists a locus on the real axis. When you are counting, you will be considering only the real axis poles and zeros, not the imaginary. Here you can see a complex conjugate, don't consider that. Now it is, we know the root locus starts from poles and end at zeros. Okay, so here we have got the real axis loci. So first step we have identified, we found the real axis loci. Now the second step is we can find the first step poles and zeros. Second is real axis loci, and this is real axis loci. Okay, real axis loci we found. Then third one is angle of asymptote, because angle of asymptote. So here phi a, the formula is 2q plus 1 into 180 degree upon p minus z. P is the number of poles and z is the number of zeros. So, and what is this q? Q is varying from 0, 1, 2, etc. up to p minus z minus 1. So, we have p minus z minus 1 is equal to um, 3 minus 1 minus 1. So, what is that? It is, so q is nothing but p minus z minus, it is varying from 0 to end point is p minus z minus. So 0 to 1 it is 0 and 1. So we are getting the angle when you substitute q is equal to 0 and q is equal to 1, find the angle here, and p minus z, you know, it is p minus z, I'll just write it here. It is 3 minus 1, it is 2. Okay. So here when you substitute the values of q is equal to 0 and 1, you will be getting asymptotic angles are 90 degree and 270 degrees. Okay. So those two things we'll be getting. Now fourth one. Okay, angle we can draw. Okay, fourth we have to find the centroid. So without knowing the centroid, we don't know from where we have to draw this angle. So centroid sigma C is equal to sigma real part of poles, the formula is real part of poles minus sigma real part of zeros. Real part of zeros divided by p minus z, p minus z. So what is the real part of poles here? Real part of pole, you can see that there are three poles, 0, -1, then -1 again. So real sum of real parts. So you'll be getting 0, -1, -1. That minus real part of 0. Real part of 0 is -4 here. So -4 divided by p minus z is 2. Okay. So we will be getting the centroid as 1. So it is positive, it is 1. I'll mark here. And what we have to do is we have to draw the angles. So we can see that it is 90° means it is, okay, I'll just draw here. You can see this is our 90°, 90°. And this one is 270°. Okay, 270. So you got the both the asymptotes. Now what is the fifth step? Fifth step is, see, we have to find the breakaway points. Okay, fifth step is breakaway points. Where is the breakaway points? What is that? So if breakaway points means if two poles are placed next to next in this one, if two poles are placed next to next, then the locus has to break away from the real axis and it should go to infinity. So here you can see that there is no two poles placed next to next. So there is no breakaway point in this particular case. So we don't have to find the breakaway point. So no need to find it. So it doesn't exist. We can write it as doesn't exist. So we don't have to find it. We don't have to find this. Okay. Uh, then sixth point, it is intersection with imaginary axis. With imaginary axis. How will you find that? Intersection with imaginary axis we will be finding by dk by ds is equal to 0. So for finding this dk by ds, we have to take that 1 plus g of s h of s is equal to 0. The equation, our characteristic equation. So 1 plus, what is our transfer function? Transfer function is k into s plus 4 divided by s into s square plus 2s plus 2. So this is 1 plus, this is equal to 0. Okay. So now when you cross multiply this, you will be getting this equation as s cube plus 2s square plus 2s plus ks plus 4k is equal to 0. This one, when you cross multiply, denominator will become 0. So numerator becomes s into s square plus 2s plus 2 plus k into s plus 4. When you expand that one, you will be getting this equation. Now what you have to do? Now for finding this one, you have to use Routh array. Okay, so now I'm just forming the Routh array. S cube, s square, s raised to 1, s raised to 0. So we will form the Routh array here. So what is the first one? First, we alternate terms only come here. So here you can see this is 2s plus ks. So I can write this one as 2 plus k into s if I combine this one together. Okay, so the second term is 2 plus k, and here it becomes 2 the second term and the fourth term. So it will be 4k. Okay, so you can find it 4 minus 2k upon 2, and here it is 0. So like this it is. Now we'll be getting here it is 4k. Okay, so this one equation is done. Now just see here. Now if you, for this one you want to find the marginal value of k, because we want to find the intersection with imaginary axis. Intersection with imaginary axis means when the root is lying on imaginary axis, that represents a marginally stable system. So for a marginally stable system, when you form the Routh array, you will get one any one row with all elements 0. So here what you have to find the marginal value of k, what you have to do is you have to find a row in which all the elements become 0. So here this is not possible. This is not possible. So only in s raised to 1, this row we can make it 0. So how will you do that? So we can do 4 minus 2k by 2. We can make it 0. So this k is actually k marginal. Okay, this k value is k marginal. So basically I can write it as k marginal. So 4 is equal to 2k marginal. So from this I can get the value of k marginal as 2. Okay, plus 2. Fine. Now, so the moment when I get this one k marginal value as plus 2, now when I substitute it in this row, what happens? This row becomes 0. So that represents a marginally stable system. Now, when this one row becomes completely 0, then you have to form the auxiliary equation from the row just above that one. So what is the row above that one? S raised to 2. So we are forming the auxiliary equation for that particular row. So we'll be getting 2s square plus 4k is equal to 0. Okay. So from this, and we know it is k is equal to 2. So we can substitute that. So 2s square plus 4 into 2 is equal to 0. So you will be getting the value of where value of s square is equal to minus 8. So which gives s is equal to plus or minus j2. So you got the value. So this is the point of intersection with the imaginary axis. Okay. So what I can do is I'll just redraw that one here. Let us not mark here. Now we after finding the angle of departure, I will mark that. Okay. Angle of next step is to find the angle of departure because we have complex poles. That's why we need to find the angle of departure. So for finding angle of departure, let me show you that. I'll just draw that one here. It is a rough sketch. Okay. We have a pole here. Okay, so we want to find this one is j1 and this is minus j1. So we have this is minus 1. So we have poles here. It is present here. It is present here, and there is a 0 present at minus 4. Okay, here. So angle of departure, how will you find the angle of departure? Angle of departure, let me write the formula first, is equal to 180 degree minus phi. And what is this phi? This phi is nothing but sigma phi p minus sigma phi z. What is this one? Sigma phi p means, suppose I want to find the angle of departure for this particular pole. Okay, let us consider this pole, minus j1 plus j1. Okay, so this one, let me consider this pole. Now I have to join all other poles with this one. This one, let me call it as P1. Okay, so I'm just joining all the other things with this one. Now what I have to do is I have to find the angle all other poles making with this P1. So this one is also, there is one angle from due to this pole also. Okay, so this is one angle. Let me take it as phi P1. Okay, let me put it as this one as P2. Okay, because P2, this is P3 and this is Z1. Okay, so now this is phi P1. Now this one I can call it as phi P3, and this one, this angle I can say it as phi Z1. So what I will be doing, so this is this distance is 1, this distance is 1. So the angle which is making here is 45 degree, and this is 90 degree, this is 90 degree. So 90 degree plus 45, you will be getting it as 135. So phi P1 is nothing but phi P1 is equal to 135 degrees. Okay, and phi P3 is again 90 degrees. So phi P3, we know it is 90 degree, because you can see from the horizontal it is making 90 degree with the P3 is making 90 degree with P2. Okay, so then what is the angle left? Now any more poles left? No, there is no pole. We have found all the angles made by the poles to that particular pole where we need to find the angle of departure. Now, what is the zero making? And what is the angle the zero makes with this pole? That we have to find. So, let me write phi z1 because we can directly calculate it because just see this. This is a triangle and the distance here, the base is 3. Here, base is 3 and height is 1. Okay, magnitude we are taking. So we want to find the angle of this one, phi z1. So phi z1 I can write it as tan inverse 1 by 3. Tan inverse opposite by adjacent. Okay, so this angle I'm getting it as 18.43 degree. Okay, so you got phi p1, phi p3, phi z1. So this phi sigma phi p is nothing but sigma phi p is phi p1 plus phi p3. What is that? 135 plus 90 degree. Okay. Then sigma phi z is, since there is only one and 1 0, we have only z phi z1, that is nothing but 18.43 degree. Okay. And this angle is 135 plus 90 degree is 225 degrees. Okay, 225 and this one. Now, uh, phi p, sigma phi p we got, sigma phi z we got. So what is phi? Phi is nothing but sigma phi p minus sigma phi z. So it is 225 minus 18.43 degrees. So that is nothing but, this is 8. This is 206.56 degrees you are getting. Okay. Now you got phi. So what is phi d formula? Angle of departure phi d is nothing but 180 degree minus phi. Okay. So 180 degree minus phi. That is 180 degree minus phi is 206.56 degrees. So that you will be getting it as answer as minus 26.56 degrees. We are finding with respect to s is equal to minus 1 plus j1. Okay, so minus 1 plus j1 pole, we are finding the angle of departure. You know, the angle of departure for angle this pole p3 will be exactly the mirror image of this angle. That will be, since it is minus 26 degree there, then it will be plus 26.56. So if it is, it will be 26.56 degree, that is plus at s is equal to minus 1 minus j1. Why it is so? Because we know that always the root locus is symmetrical about the real axis. Now we can complete the root locus. Let me draw it here. It is just a rough sketch only. I'm just drawing. Okay. No, 0, then minus 1, minus 2 will come here, minus 3 will come here. This is, we have minus 4. Okay. Then we have j1, then here it is minus j1. Okay, so this one we have to mark the poles. It is already done. I am just redrawing it. Here we have two poles. Here at 0 we have one pole, and here we have a 0. And we have already found that there is a locus in this x-axis. So that is, we are marking with a dark line. So here it is, the one locus is starting from this pole and ending here, and centroid here we found that centroid is at 1, and angle of asymptote we found it as 90 degree and 270 degrees. So this is our 90 degree line and this is our 270 degree line. So both we have drawn. Now the angle of departure at this pole, we found that it is minus 26.56. So this is the reference we are taking. This is the reference. So minus 26 means it will be in the clockwise direction we have to measure. So this is minus 26.56 degree I have drawn. Similarly, on this side, we will be taking a positive angle, the same angle, symmetrical. So 26.56 degrees I have drawn. Now, so that means the this and what is that intersection point, we found that it is at plus or minus j2, right? So j2 also we have to show here. So it is j2 and this is minus j2. So intersection point we found from that breakaway point equation. Imagine intersection with the imaginary axis, that is dk by ds is equal to 0. Then there is no breakaway point in this particular problem. So this locus is starting at an angle 26.56, but at the same time it should cut the imaginary axis at this point, and it is going like this. Okay, so here also it should start at 26 degree, and it should be just intersecting the imaginary axis at, and it should be going like this, because root locus will be going as same. So this is the thing. So now it will be ending at infinity. So this is the root locus which we are getting. So you can see that there are three. One part is from 0 to -4 starting. The another one is from this plus j1, -1 plus j1. That pole is ending at infinity. Then -1 minus j1, that is ending at infinity. And it is cutting the imaginary axis at j2 minus j2. Okay, so this is the complete root locus of this particular problem. So this is sigma, this is real axis, and this is imaginary axis. Now suppose we want to find the comment on the stability. How will you do that? Now there is a ninth step, that is prediction on stability. How will you find it is the system is stable? Here till the imaginary axis, when the roots are lying on left hand side of the S plane, then the system is stable. The moment it crosses this imaginary axis and go to right hand side, it becomes unstable. And when the poles are lying on imaginary axis, then it is marginally stable or limitedly stable. So here in this particular case, what are the values of k for which the system is unstable, stable, and marginally stable? We can find k marginal, we have already found, that is so for 0 less than k less than 2, all the roots will be lying on left hand side, though. So the system will be stable, okay, because all the roots lie on left hand side of the S plane. At k marginal, we found it is 2. So at that time, you say it is marginally stable system. Marginally stable system, okay. Marginally stable. Then and we found that S is equal to, we have found S is equal to plus or minus J2. So S is equal to plus or minus J2. That means it is J omega. So omega is equal to 2. So this will be oscillating at a frequency 2 radians per second. Okay. Now for K greater than 2, the system becomes unstable. Okay. So this is how, so unstable. So you found that the stability of the system depends upon the position of the root locus. So you can comment on the stability also, and you can just see this. I hope you understood how to draw the root locus using where the transfer function is having both poles and zeros. We can just see the transfer function, I have taken a transfer function in which you have a pole, we have a zero is present and pole is present. You have to follow all the steps. Okay, fine, thank you.